Hello everyone, and welcome to meetup number 10. I'm Julian from Token Engineering Labs, and today we'll talk about a token engineering tool called Machinations. So our topic will be from specification to modeling and mechanism design in Machinations. And for this, we have invited Curiousrabbit, who is a known system designer and contributor to the token engineering space. So personally, I have no experience with Machinations, but always wanted to take a closer look. So I'm very excited to have this meetup today. In terms of agenda, we'll have a walkthrough through Machinations. We'll have all the advantages presented by Rabbit, and then in the end, we'll have time for all the questions. So as always, feel free to raise any questions in the chat, and we'll address them at the end. So welcome, Rabbit. It's great to have you here, and feel free to start your presentation.
Cool. Thanks, Julian. So this is the first time I'll be doing this presentation. I ended up combining insight from the book Thinking in Systems. And as we go through those insights, I'm actually using Machinations to show us, well, this is how Machinations helps us accomplish this thing. There'll be some elements of specifications or understanding like how to model things, but that's not the core of this, just because it's a bit more advanced. Understanding, how do you take mechanisms from a system and then model user behavior to get KPIs to then feed into another system to model like a whole system. So this will be a good starting point. Hope everyone enjoys, and let's get to it. Okay. All right. Let me lower this. Cool. Can everybody see my screen?
Yes.
All right. So, Curious Rabbit talking about Machinations, and I just wanted to give a shout out to Donna Meadows and her book, Thinking in Systems. What we're going to cover today is we're going to cover some principles in systems thinking. We're going to look at three parts of a system, in particular, elements, interconnections, and purpose. And we're going to look at stock and flows. And as we go through that, we're going to be going through theory and then shuffling over to a Machinations model to kind of look at how that theory takes or manifests itself in Machinations. So we'll be looking at benefits, examples, and some basics. We'll really only be covering the basics of Machinations, and that's just like, here are some nodes, here's how it works towards the end. We'll just see how much time we have left for that. So what's a system? So a system is a set of things that are interconnected that create a pattern of behavior. And almost everything is a system. In fact, it's hard to try to think of something that doesn't fall into that category. And so that's what we're really doing here is we're building new kinds of systems in Web3, and we're trying to leverage tokens. And today we're talking about, well, how does Machinations help us do that? Now, I was in a meeting the other week with a firm that uses Machinations for their clients. And one of the questions was, what is one of the benefits that they've really found using Machinations or since they've adopted Machinations? And one of those that he communicated a few times was actually Machinations helps them communicate the concepts and the ideas of the system they're trying to create, of the token economic system they're trying to create to the client. And I love this line from the book. And it says, words by necessity come one at a time, but systems happen all at once. And it speaks to why visualization is such a powerful tool when we talk about Machinations. And let me just up this thing. So here is just something super simple that I just put together, right? It's a visualization to talk about a concept and to just, reinforce what I just talked about. What we're doing here is I'm actually depicting the velocity of money, okay? What I'm showing is I'm showing how a business gives $1 to an employee, that employee spends $1 at the fruit store, that fruit store spends something at the mechanic, and then the mechanic, it goes into his savings. And the velocity of that dollar, which is the value amount of transactions divided by the money supply. So in this case, it's 4 divided by 1 is 4. And this is just a really simple example to show how you can take concepts that are kind of hard to grasp. But when you use a visualization tool like this, it becomes a lot simpler. All right, let's move on to the next one. So this is a really interesting line. And we don't have to, you can feel free to read the story, but the idea here is that the system causes the behavior of the system or greatly impacts it. So this is a story about during British colonial rule, there was too many venomous snakes. So they created a reward for people that killed snakes and brought them. And as they like to say here in a beautiful demonstration of second order thinking, citizens began to breed these venomous snakes to kill them to bring to the British army. And by the end of this whole thing, the snake problem was worse than when it began. Now, we might look at this and we might say, oh, this is a case of incentives gone wrong. But if we look at the overarching system in which this incentive took place, we see that it's a system of scarcity. You know, it's our modern day economic system is one based on scarcity. And that kind of system, that kind of structure elicits a kind of behavior. Because you could imagine the same incentive, but what if it was in a society where everybody felt like they had everything they needed? And that in fact, they were doing this out of the goodness of the heart. I know that sounds very utopian, but it's just an example. So Machinations, what it can do is it can help us understand the parts of a system. It can help us see the interconnections. It can help us ask what if questions about the possible future of this system. And then taking that feedback, we can help redesign the system to be better. Give me 1 sec. I just need to copy paste. Oh, that's not what I wanted. No, why did that happen? Huh. Sorry, 1 sec. When I did this before, it worked. Oh, that's what I did. So this is an example of a system that I built based on an A16 article about paying people to participate in governance. And as I did this, I started to notice different parts of the system. And I started to ask, well, what happens if people ask for too much rewards? What happens? How much does a DAO end up overpaying? And by building the system out, I was able to start to ask those questions and inquire deeper, and I identified different elements of the system. And we're going to go through this model a few times throughout this presentation, but I just want to give kind of a basic thought on it. All right, let's move on. So there are 3 parts to a system: elements, interconnection, and purpose. Now, the elements of the system are really the things, the tangible, visible things, and they're often substitutable. If we're looking at a Web3 system, and it might be something like, okay, well, let's substitute one AMM for a different AMM. In Machinations, the elements that we're particularly concerned with are the ones that affect the token economy. Now, let me just copy paste. So I had said I was going to do a project a while back that I never actually ended up, ran into the same problem. Does this work? No. Sorry about that. Sorry, when I tried to have all these windows open at the same time, it was just too much. So I had taken on a project that I never ended up following through because of time constraints, but it was about the sandbox and modeling the sandbox. And when I wanted to model the sandbox, what I was really looking at is I started to identify what are the parts of the sandbox, the actions within the sandbox that have an economic impact. So I'm not really looking at, a user jumping and running and doing these sorts of things, I'm looking at the elements of the system that will have an economic impact. And let's take a look at this one. So this isn't a system that I built. This is a system from Thorify. And if we look at the Thorify system that they've built, what we're going to notice is that the things that are being illustrated here are the things that are having a direct impact on the economics of the system, right? We're not looking at the user logging in into the MetaMask wallet. We're not looking at a whole bunch of abstract actions that are necessary for the user to get to this thing. We're abstracting away a lot of the complexity to try to really get to the rewards, the economic assets in the system and how the relationships between these economic assets function. All right, let's move on. So the behavior of a system, though, cannot be known just by knowing the elements of which the system is made. And that's where we look at interconnections. Interconnections are the flows of information. They're the relationships between elements, like the rules of a game. Machinations, it helps us look at how different elements are connected, right? How the staking of this gems will create how many pieces of armor that will then be able to be sold as NFTs is we can look at these relationships, these mathematical relationships. We can tweak them, we can test them, and we can simulate healthy parameters and unhealthy parameters. So let me just take you through. This one will work better. So one of the ways, right, all these are actually mathematical relationships. All these are ways of depicting interconnections in machinations. What we're going to look at right now is we're going to look at logical functions, because with logical functions, you can nest so much like logic, so much action flow can be nested within logical functions. And it's a very useful thing because Machinations is a Turing complete system, which pretty much means you can depict any kind of logic that you want in Machinations. So here are some examples. This actually was built by Benjamin from Jarvis Labs when we were discussing logic gates. Now, logic gates, what we just went through, it allows us to say, well, you know, imagine this is some sort of Gnosis Safe wallet or whatever. And it only will get triggered when all of these things are true. And there's a whole host of logic that you can program with these sorts of things. This node in particular is called a register. And this register is what allows us to depict all sorts of mathematical logic. Let's take a look at these logic gates in action. All right, so back to this model. So right here, I have a logic gate. And this logic gate is signals whether tokens have been voted or not. And it allows me to demonstrate, you know, what would be user behavior in an application. And it really is quite useful. And it really is like, this is just one way of depicting that same kind of behavior. Because Machinations is very flexible, there's multiple ways that I could depict this kind of behavior. And we're going to see once this model plays out that once quorum gets reached, this ends up being triggered. And it's been a little while since I've looked at this model. I kind of forget where everything happens. I'd have to read through it. And quorum should be triggered shortly. I don't know. Anyways, let's move on. It's not really important. So next, we're going to look at the purpose of a system. The purpose of a system is deduced not from its behavior, is deduced from its behavior. It's not deduced from its rhetoric or stated goals. What I love about this is it takes away intention, because what they say, the road to hell is paved with good intentions. And frankly, that's not good enough when we're building systems. It's not our intention for the system, it's the actual behavior of the system that we want to test. And my question to you is, what is the purpose of a debt-based economic system? I would love to hear some answers in the chat. And one way to define what the purpose is of a debt-based economic system is to look at its behavior. And the behavior that we've observed from this debt-based economic system is continuous growth at any cost. And so we have all of these incredible movements, to improve the world, to stop consuming all this stuff and blah, 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 blah. But the underlying structure on top of which everything is built actually incentivizes and creates the behavior of continuous growth. And when we're looking at building the systems that we're building in Web3, it's important to understand the structure in which we're building, because that itself creates the behavior. So as we just said, the best way to deduce a system's purpose is to watch for a while and see how it behaves. And Machinations is really good with this because it allows us to do Monte Carlo agent-based simulations. So I'm going to take a look at an article that Jarvis did on Axie Infinity. Continue reading. And this is what the model looks like. Okay, so it's quite complex. And we're going to go through a bit of, well, how do you actually get KPIs or key performance indicators from this model that makes sense? But let's take a look. So this is the chart produced by a price simulation of SLP. Now let's look at the actual chart of SLP. This was built in Machinations. And this is what Machinations enabled them to identify and predict is the unsustainable stock and flow dynamics of SLP before it ever happened. So if we go back to this model, here, sorry for the clunkiness of changing screens, just couldn't do it elsewise. So here in Machinations, I can identify two nodes. So let's just do this from the get-go, remove from chart. Remove from chart. So I'm going to choose total rewards, and this one is this is like the amount of rewards given per 1,000 votes. Okay, and now I'm going to do something called batch plays. Batch plays are the Monte Carlo simulations, and when I have randomness or probability or uncertainty in a model, it enables the model to run multiple times, right? So I can do a number of different batch plays over a number of different steps. So if you can imagine one model has, or one play has 100 steps, it's going to be 20 plays times 100 steps. And I can see the different outcomes. So let's just give that a whirl and check out what happens. And remember, right, that we talked about the impact of being able to visualize a system. And we're going to look a bit later at the idea of how system thinkers use graphs to visualize trends over time so that we can anticipate them. And this is something that Machinations is quite good at. All right, that's done. So let's take a look. So what we see here, so if register 1 is the amount of rewards given per 1,000 tokens voted, total rewards are the total rewards that are given, considering the amount of rewards per 1,000 tokens. What we can see here is that it ranges from 100,000 to 300,000, 500,000, that there's really a broad range. And so the insight that I derived when I was working this model is that we actually need to provide constraints to the total rewards that a holder can ask for so that we don't have such a broad range and we don't end up overpaying voters to hold. We don't end up overpaying holders to vote. All right, let's move on. So just a quick recap of what we've gone through so far. So the first point was that systems happen all at once, and being able to depict them in a visual way is super valuable. Machinations helps us with that. The other part was that the structure of the system causes the behavior of the system. Machinations can help us understand the parts, relationships, and purpose of the system by having to draw it out, by having to design it out. We saw that systems are made up of elements, another word that we can use for is mechanisms. In machinations, we focus on the ones affecting the economics of the system. You can imagine if somebody is performing an action that doesn't have an impact on the economics, we can usually abstract that away. And the actions we'll want to show is going to be like the staking mechanisms or the liquidity mechanisms or the trading mechanisms or the treasury mechanisms or whatever it is, the distribution mechanisms. We saw interconnections. Interconnections are the relationships between elements. Machinations helps us model and simulate these relationships and then test to see, are these parameters healthy or not? Now, the purpose. A purpose is a system's function. It's the output it creates. It's not the rhetoric it spews. I really love this. I don't know why I love it so much, but it just takes away beliefs and ideal, and it looks at what's the outcome that this system is creating. And in machinations, as you saw with the Monte Carlo simulations, is we can start to anticipate what might be the output of a system. All right, so let's look at stocks and flows. Now, the foundation of any system are its stocks. These are the quantities of things moving throughout the system. And stocks, they change over time through the actions of flows. Flows, those are the faucets, the drains, birth, deaths, the purchases, sales, growth, decay, deposits, withdrawals. And if you understand the dynamics of stocks and flows and their behavior over time, you understand a good deal about the system. Machinations can help us understand the impact of flows on stocks by modeling it and simulating it. As we just saw in this example with Jarvis and Axie Infinity, is that when you start to model the flows of the tokens in the system, you can and the stocks and the way that they move, you can anticipate what's going to happen. And if you can anticipate what's going to happen, you can tweak the interconnections of these things, the mathematical relationships between elements that are happening between these nodes. And that can help you design your system in a more sustainable way. So a stock takes time to change because flows take time to flow. And we use graphs of system behavior to understand trends over time. I don't know what happened to this line right here. But to illustrate this, if we go back to what we saw in Jarvis, but also what we observed in this template here, is the impact or the utility of having a visual of what might happen in 20 different scenarios. And imagine you did 100 different scenarios. And then imagine you average that out. So you got the average, the minimum, and the maximum. The impact of that on a project when you're communicating it to the core team is super valuable. And here in Machinations, you can change a bit how it's viewed. Let me remove this just because it's so small. And let me do this. All right, well, that's not the best, but anyways, you can tweak with the chart to get clearer charts. You can export the chart. You can even export the data that you collected as a CSV file that you can then import into Excel and things like that. So in the physical world, I think what this line wanted to say, in the physical world, stocks act as shock absorbers because they take time to change. The interesting thing is that this changes in the digital world. So imagine you have a forest, and the stock of the forest is the amount of trees, and either you can only cut trees down so fast or they can only grow back so fast. There's a time lag between that flow because of physics. This changes systems. right? Because we're not necessarily limited by physics, and things happen extremely fast because of the interconnectedness, which means that the shock absorbers that we have in analog systems, which are stocks, aren't necessarily as robust or as able to absorb shock in digital systems because the flows happen faster. And that's why Machinations, for one thing, is so important, because it gets us to be able to clearly look at the stocks and flows of a system, simulate how they change, measure key performance indicators that help us place constraints on the boundaries of a healthy and sustainable system. And that's kind of like what we looked at when I saw, oh, we need to place a constraint on the amount that each holder can ask to be rewarded for voting in governance systems. If not, we end up overpaying too much. Now we'll go over a couple basics, really just the pure basics of Machinations, just so you get an idea. I'll show you the community diagrams. They also have a Discord and really helpful YouTube webinars. One of the really cool things about Machinations, and let's just create a new file, is it's a really small learning curve. With about 4 hours of dedicated effort, you will understand this whole system, okay? There's not that many nodes. These nodes are fairly intuitive. This one is called a resource generator. This one is called a pool. You can imagine a pool being something like a wallet in Web3, or something that is holding assets. You can imagine a resource generator as something that is generating assets. We briefly saw the register. The register is like your data, right? It's taking information from the pool, creating a variable that's inputting it, and then we can use that to output something else. So here, I have another resource generator. I have another pool. I'll have another connection here, and then I'm going to have this impact that. And let's just go, and you see how what's happening in this register is impacting what's happening here. So Machinations is a very simple tool. And one of the things so everything I discussed today in Machinations is doable today. But already we're starting to see things like custom variables and global variables. What this is it allows us to take data from, let's say, a live market. Right now we have Binance available. Let's say I'll choose, let's go ETH USDC. And you can imagine a future where you have live market data that is being plugged into a system where the mechanisms have been mapped, and you can see the stocks and flows in real time. What did I have to do? Let's do this. This ETH. So Machinations is really an easy, intuitive tool. Let's go to settings. Let's go to the community profile. So in the community profile, they have a bunch of diagrams. Now, these diagrams are a great place to start, because you can go into these diagrams and you can fork them. You can start to tweak and play around in them and understand how do they work. They also have a Discord community that you can use, and they have great YouTube videos. I think that is all that I wanted to cover for today. Like I said, I'd never gone through this, so this only ended up being half an hour. But happy to answer any questions. And I want to say a big thank you to TE Labs for this event, those who attended, the TA for your course, the TEC, Token Engineering Commons, for supporting token engineering, Machinations for your wonderful software and awesome team, and Donna Meadows for your book.
Amazing. Thank you so much for this presentation. It's been very interesting to getting to know this tool as well. I think we already have some questions in the chat, so we have some time left for that. So the first one we have is thank you for a great presentation. And I would like to know how you go about systems engineering when someone, for example, a client, explains an idea to you and then you have to design a system. It is often the case that people find it difficult to describe all the requirements in concrete terms. At least this is my experience, said Bernard.
So I'm still trying to figure out a way to do this simply. I am building a model for this. So far, the way I'm looking at starting is starting with, okay, what does the traditional industry that you work in look like? How does the value flow in that traditional industry? How does that get disrupted in the Web3 industry? Because I think a big thing in Web3 is how we remove intermediaries. So you can imagine if you're removing intermediaries from the value chain, that the value that they've been capturing can now be captured by the business. So to take a step back, I'm starting from the base point of how is this business capturing value? Because if you're designing some sort of token system, I want the token to have some form of value behind it. For it to have value behind it, this business needs to capture value and then redistribute it in some way to that token. So I don't have a good answer for that now. I'm trying to see how can I simplify the process and abstract away all the complexity of requirements and incentives in the beginning to start with the fundamentals of, well, what value is really there to start with, so that we don't end up with tokens that have requirements, that have incentives, but that have no inherent value. And so when the tide goes, everybody is seen, naked and shirtless and whatever it is, because really there's no value to this token. Even if you define a system with requirements and a system with incentives, if there's no inherent value to it, I don't know if it's sustainable. So that's where I'm starting. And sorry, I don't have a better answer for you.
Bernard, do you have any? I can unmute you if you would like to have a follow-up question.
It was already a good answer. Thank you a lot.
Perfect.
Cool.
Yes. Okay, cool. Thank you so much. And then we have another question here. How do you approach the time concept in machination simulation? As long as a step represents one transaction on the blockchain, things are simple. What if we want to answer the customer question? What will be the economic impact after 14 days? Where can I see it on the chart? How do you go about it? And do you make assumptions like one step is 1 day?
So that's a great question. Let's I'll share my screen again just so everybody can see what a step is. Let's go to sorry, one sec. Okay, so these are steps. Okay. And defining a step is an important part of a model. And a step usually, for me, represents some sort of time frame. A step can also represent an action, like a user login, but you have to determine what does the step represent in your model and then make your model consistent throughout, right? So if the stocks and the flows of a certain area, of a certain thing represent the stocks and flows of 1 day, I can't have a part of my other model where the stocks and the flows represent 1 month unless I do some sort of time lag, some sort of interval. So if one step is 1 day, let me clear this out. So if one step is 1 day, and then I have another variable where the stocks and flows only move every 30 days, one way of doing that will be putting in an interval. And what you're going to see here is that this one's only going to get triggered after every 30. Another way of going about this, right, is so let's say you define what a step is for a certain number of variables, but you need to trigger other things. Well, you might do something like a register. And so you know that after 30 days, that pool will have 30 tokens. And I only want this to get triggered when this is greater than 29. Let me passive. So this effectively will only get triggered when this is greater than 39. So you have to find creative ways of going about this is pretty much the answer. Once you define what a step is for some mechanism in your model.
Man kan summera deine Machinations, deine Kontoauszug.
What's that?
Maybe that wasn't a question. Yeah, great explanation. And we have another one here. Is it possible to add stat distributions or probabilities to a certain gate to make it more accurate? I saw similar software for process reliability assessment where this is possible. That is why I'm asking or making this lateral thinking.
Is it possible to add probability and what? Probability, yes. I didn't get the second part.
Stat distributions. I'm not sure what it means. Maybe in
statistical distributions, I guess. So, I mean, you can create, if you had the statistics that you wanted to use in the model, you can create arrays. And here, let me share my screen once again. No, there. And just a heads up, guys, I actually only started using this tool about 3 months ago. So I'm by no means an expert, but randomness function is one way that you can create probabilities with different kinds of distributions. So that the Gaussian is kind of usually more around the mean and the uniform is throughout. You can create, let me remove that. I don't want this. Cancel. You can create, math expressions as arrays, and then you could input your stats in that. And then you could have the array triggered depending on how many resources are in a pool sort of thing. Also, I know that Alex from Machinations is here. I don't know if you have any insight that you want to add to that question.
Hello. Yes, I'm here. What was the question? Let me read the question.
It was, is it possible to certain gate to be more accurate? I don't know where the question.
Is it the question about the distribution and probabilities with the gate?
Yes.
Yes. If you can go on the model and open a gate, put a gate there and connections. We can show that you can actually put in there any percentages to change the distribution. I don't know if that answered the question, but that's a feature. Can you hear me?
Yeah,
yep.
We can hear you. Do you want me to do that right now, or
oh no, you don't have to do it, but yeah, to the short answer is yes, we can.
Cool. Great.
And I'm looking at the following question regarding accessibility. Is there a way to use machinations with some sort of mute settings? I really like the concept, but I had troubles getting through initial tutorials because of the high contrast and flashy animation. We don't have dark mode yet, if that's the question, but there is a way for the user to change the background with any color you like. So you can have a black, red, yellow background if that helps. If that's better for you.
And is there also a possibility to change how the animations are displayed? Because they are quite flashy. So if they sort of
so what you would need to do, but this will change the speed of the animation. No, Curiousrabbit, maybe just open a model there, and you can actually change the speed.
Yeah, let me.
Which the diagram is running.
So
So you see, just next to steps, you have speed. And you can change that. So it means that the diagram will run slower. But it also means that it will take more time, you know, if you want to manually run a simulation. But
so yeah, now it takes 5 seconds between each
Yeah,
step. Sorry,
between
this
each
model
step.
always makes my computer lag. But you can change the speed, and you can also go step by step.
Oh, and if you don't really want to see this animation, you can also play with batch plays. It means that you will not see the simulation actually running. It will run in the background, so you won't see anything moving. You will just see the results once the batch plays are done simulating.
There's a question from Chris about
Yeah.
using a mathematical specification before modeling. So the multi-dimensional bonding curve one is just a good simple example of that. But also very quickly, if the flashiness is getting in the way, if you make things instant, then you don't really see the resource move, right? So I can make all of these things. Actually, I think that was the only one. So I can make all of these things instant so that you don't actually see all the resources move throughout. To answer Chris's question about a mathematical, so when I was learning machinations and learning about bonding curves, right, I would break down some sort of formal definition of a bonding curve, understand it the best that I can, and then break apart the variables. So supply of token 1, token 2, R is the reserve asset deposited. So I make a node pretty much, or a register for each of these variables. And then I use these registers to define the mathematical relationships between them. And here, what I depicted was a multi-dimensional bonding curve where there are 2 tokens being emitted for the reserve token. One of them is a stable coin, but because the stable coin its value is also a factor of supply of token 1, they change the supply of token 1 to keep the price of token 2 at a stable $1. I hope this is like a reflection of a formal definition being depicted in Machinations.
Cool. Yes, and then we have, I think, a comment from Stefan, who said that about the debt and money system of our society, I think that the problem is interest debt and not the debt itself. Don't you think? Isn't every monetary system a sort of social debt system? So it's a comment on your earlier question.
Yeah, that's interesting when you look at like what the history of debt or 10,000 years of debt, and that actually debt was always used even in bartering societies kind of thing. It's like, oh yeah, thanks for the goat, I'll get you back. Yeah, I guess what I'm particularly referring to is the debt to GDP ratio, and how when you have a sustained economic contraction, it would create so much default risk at this point that it necessitates that we continue to grow despite, let's say, reaching the constraints of resources on the planet or things of that nature. So the actual structure of the system makes it so that if we actually stopped growing, it would collapse. And because that is a horrible outcome, it's almost like we're in this vicious cycle. But yeah, I think that you're right. And I'm not really an expert in the history of debt and how it's played a role in the development of society.
Cool. We have a thumbs up from there, so I think all's good. And then we have Phoenix that wonders, what is the best way to check that a model is appropriate to the system design? Is there a way to interact with the API to check the state of a system?
So I think in the future, I'm hoping that there's going to be a lot more integrations between Machinations and other tools that will kind of allow for these live updates sort of thing of the state of a system and it being reflected in Machinations. What we have now is we have the ability to take data and turn it into a JSON file and then use that as a variable in Machinations. It's a pretty new feature. And like many things, there's so much potential in the future to allow for these systems to speak more clearly to each other. Right now, it's a bit clunky. What is the best way to check that a model is appropriate to the system designed? I think as the builder of a system, there's kind of like a step-by-step process. Is first you create the elements that you want to model and you talk to the project and you're like, hey, do we agree that these are the parts of the system that we want to model? And then we start to look at, well, what are the KPIs that we want to measure to test the state of this ecosystem? And those KPIs end up being like the output of user behavior. And I guess it's up to your judgment to decide whether or not it's appropriate for the system designed. There may not be a formal way to distinguish that right now.
But yeah, if I let me turn maybe my camera for a second, so we can proceed when I'm speaking. So just to complete a little bit the answer, I think it's something very hard to do because there is no way to standardize, the answer to this. So as Curiousrabbit says, like it's a very, it really depends on the project. What's an appropriate model. It's really specific to projects. It's not something that you can easily standardize. Yeah, that's my answer. If it makes sense.
Yeah. So my intuition tells me that what we're doing right now is we're building new business models for Web3 and new coordination frameworks for Web3, or new coordination frameworks for these business models. So we're not sure what works yet for these new kinds of systems. Once we have working models, it's going to be a lot easier to verify, like, well, here's the standard. Does this meet that standard? We don't have standards right now. We're in the experimentation phase.
Great. And another question here is there something like slicers or levers to play with variables between runs to build different scenarios and compare outputs after changes later? Is there a way to plot this into a surface graph, like a 3D surface, to learn about interactions and best place to work or the best variable settings?
What were the first words? Slicers and levers?
Yeah.
Can you repeat? Oh, is there something like slicers and levers play with variables between runs to build different? So to build different scenarios, what you usually do is you can change. So let's say you have different user personas, okay? And these user personas, it's almost like they have a probability of doing an action. Now, for different scenarios, what you can do is you can change that probability of them doing that action, or you can change the trigger to that action. Because in these systems, you're going to have like users doing actions and these actions trigger things. You can change the trigger and you can also change the probability of that action being triggered. And that's how you would run different scenarios. These different scenarios, you would want to have a node that identifies the output of these different scenarios. And then you can export that as the CSV file, and you have that data that you can then use or leverage in other ways.
Cool.
Oh, yeah, and for the last part about the graph, no, there is no way to plot this into a surface graph in Machination, but you can definitely export the data and do whatever you want with the data.
And also, like, look, guys, if you get good at this now, will the functionality of, let's say, being able to export or integrate the data being compiled in Machinations increase? Yes, right? So in 2-3 years' time, how will we be able to use the data that Machinations creates? It's going to be a much more dynamic than now. I can imagine a day like in Figma where you can export your model as code. I don't know if we're going to be exporting our data as code, but we'll be able to use it much more flexibly, is my intuition or anticipation.
Cool. I think we ran out of questions in the chat. I have a question as well. I was just wondering, just like about the tool itself, and as someone who might consider like using it henceforth, is it something that is missing? Do you still have to interact with other tools as well, or can you like do the full modeling from basically start, or from that you have a specification to finish?
So if you've done the discovery phase of a project and identified the mechanisms of the project and the sort of stakeholder analysis, so you have the user personas, like if you've done all of that work, then there's nothing I can think of right now that you can't model for, you know, anticipating the behavior of the system of stocks and flows and how the user persona will affect that, or adding black swan events and stuff like that. But I'm sure that there are things that you can't measure and model. I'm not an expert in simulation, really, so I don't know all of the elements that are missing. Alex, do you have any thoughts?
That's a good question. If there is anything that you cannot model, again, my answer would be there is things that you can model, but they don't make sense to model with the tool. But yeah, as Curious said, the tool is like Turing complete language. So you can model anything you can think of. You know, like just for the fun, I model a timer to cook eggs or things like this. But yeah, you can model anything. But if it makes sense to use Machination to model them, it's another question. That's my answer.
One of the questions that came up in the Discord that I created was, what tools are there for modeling bonding curves? And Machinations is actually a great tool for modeling bonding curves, because all it is it's taking a bunch of variables. So if you already have a formal definition of something, you just create these unique variables within Machinations, and you have it all input into a register, and you just measure that register kind of using batch plays or whatever. And you can kind of get a range of, oh, this is how it behaves in a whole number of situations. So it's particularly good for modeling formal definition stuff, I find.
Great. And I think Chris also posted a question now. He would like to know how an action or a mechanism is implemented. Do you have an explicit example of such state update specification? Given I have such a specification, how would I implement this into the tool?
I believe that to see an action is implemented. Do you have an explicit example of such a state update specification? Given I have such a specification, how would I implement this in the tool? And of a state update specification, do you mean like the model, we want to add something to the model, or we want to tweak some sort of variable? How would you add this to the tool?
I think in general, the different changes that would happen in response to the mechanism. So if one mechanism is triggered, then like what would be the outcome on the system? What would be the state update that happens once the mechanism is triggered?
So this is the process that I learned from Machinations. I don't know if it's like to discuss at the moment, but very vaguely, it's almost like if you can define the KPI of the thing, and that creates the state update, then you take that data and you implement it as data input. So you take the output of the KPI as input to the model of the whole system. I don't have an example that I can use of that right now, but you can imagine just like different levels of granularity. So here's this mechanism generating this output. You take this output as input to the larger system mechanism. I don't have an example of that right now.
Yeah. Okay. Thank you very much. Sorry, I was a little bit constrained with speaking before, but the idea is to understand how you would, given you have a bonding curve, given you have, for example, you trade on a bonding curve, you have an AMM, you have anything that would trigger a system update based on a particular curve, and then you allow users to take particular actions. So you say, let me swap in, let me swap out, let me add liquidity, let me change parameters, whatever. Like there are some things that you define. That you would want to have agents being able to do with this system that you've specified. Mm. So now, given the set of actions that you have, you will see that each of those actions will have an impact on system states on the global or on a local level. So now I'm asking if, given that I had such a specification, so I know exactly what is supposed to happen with the system if one particular action is taken, and I have those formulations already in front of me, how would I implement this in Machinations? The question is because you showed us, a logic condition, or you showed us a bonding curve, but I want to look deeper into, what are the formulas that you, like, where do you put them in? Where do you plug them in? How do you make sure that the system performs as intended?
So the first part of the question it goes back to what I just answered, which is different levels of granularity, right? So you have a defined behavior of a user persona, and you have the model execute that user persona. That information or data becomes data input for, let's say, well, this is how this behavior is affecting the whole system, or this is how this user is affecting the whole system. So you go from like the behavior of one user for the data output to then using that as almost the behavior for the stakeholders, creating this is the reaction in the whole system. Where the math goes, it's really quite simple, right? It's these registers. Let's I think I have. Let me do running here. So here, what we took is, and this is like when I was learning months ago, is we took these equations, carrying capacity, max sustainable yield, population growth rate. We defined each variable, right? These variables then go into another register, and this register is the carrying capacity, right? So we have the formal definition of the carrying capacity, and then that ends up affecting how the fish stock is responding. Or how people are responding within the system. I don't know if that answers your question enough. Feel free to outline it more, or like discuss it more if you want to.
Yeah, great. Yeah, it actually answers it partially. So thank you for showing me this. This is exciting. But the follow-up question, obviously, I have one here is, what does it, is it possible to build multi-leveled models as well? Or is it only possible to build system dynamics models as you have shown here with the equations, right? Because the ones that you've demonstrated would specify the changes in quantities of your population, but only on a macro level, right? You wouldn't have any agent behavior here implemented.
No, so what I would do though is forget fish stock and whatever. Imagine this here is agent behavior, okay? And the KPI from this specific agent, let's just call it agent 1, ends up being this thing of fish stock. Now I take that data and I input that data in a larger model. So if you try to implement, so here I then take this data, let's say I put it into an array, and this array ends up becoming the thing that is triggering the next level of granularity I want to see in the model. If I tried to build too much into this model, so if I went from like user persona and then that going into, let's say, a larger mechanism, at least on my laptop, it usually ends up freezing. I think that's just because of CPU performance. So I kind of need to create different models so that I can have them function properly. And Alex, I don't know if you
Okay.
want to add to that.
Sorry, can you repeat?
I said, I don't know if you want to add to that, is all I said.
No. I think you provided the right answer.
Perfect. So final question then: as the models that you're showing, are they open source, or can I look at them? Can I study them myself, or is this proprietary work?
Most of the stuff I showed today is open. It's all just, most of the stuff is just stuff that I just made on a whim as I was learning this tool. What you can explore too are the diagrams here. And one sec, let's let it load. So the diagrams here, you can explore, you can fork. This was actually made by Chris. Chris started in our study group at the TEA. And this was him. Sorry, it's just taking a minute to load. Let me close that. And this is him measuring, I believe it's like the staking and reward mechanism for Avalanche. And so you can see I just forked it. One sec. So you fork it, and now you can tweak it. And you can play around with it, and you can dissect it. And that's a great way to learn how to use this tool.
Great. We'll have to look into that and try some things. I see one question here from Saremba. Maybe you want to unmute yourself and ask it yourself.
Yes, thank you. So you already talked a little bit about testing, but I was wondering, how do you approach testing in the general setting? So when you put together your models, how do you go around testing in either whether the specification works as expected, or if your translation from the specification to the actual Machinations representation works? And okay, the next part I'll ask in a moment. So do you have your way how you always test, or something that you might suggest others?
I don't feel like I have a framework set up at the moment with which I am satisfied with. I feel like I'm still learning quite a bit about testing. So projects don't necessarily even have the formal definitions of like how they want their mechanisms to work. If a project came up to you and they had like, oh, here's the formal definition of our bonding curve and distributions and all these sorts of things, it's like, wow, let's model that out. That's great. That's easy. I am not a math expert, so I don't necessarily have the capabilities of defining complex formal definitions for crypto-economic primitives at this point. I feel like that's something I'm still learning. So my go-to tool is usually either to refer to somebody that is like a math whiz, or use already existing crypto-economic primitives. So it's like, okay, well, let's say we're going to do a liquidity bootstrapping curve, and we're going to leverage this mechanism. So you can get pretty much the formal definition from Balancer for their liquidity bootstrapping curve. You can input that into your model in Machinations, and then you can use that. But it's like a messy process at the moment. For me,
I'm asking because I thought it did sound a little bit messy if, for example, you wanted to test scenarios and you needed to like include each element of the scenario and give them different probabilities. And I was wondering if that part is maybe more about just making sure that the model that actually is inputted in Machinations is as planned. If there is something that would be comparable to unit testing, so where you build subsets of the model and test them, because the way I see it, it sounds actually very like potentially difficult. What do you think?
So it's multiple steps, right? It's not a one-step process. The unit testing. Let me see. Let me just try to get to a part on the page. Okay. I can't share all this document, but I can share this part. So, you know, like you need to develop, okay, what is the range of probability of a user in normal behavior, and what is the range of probability of the user in abnormal behavior? And then you need to test those various different scenarios. And it is multiple steps. I think, you know, Machinations, like Alex from Machinations and Machinations, this is what they do. This is what I just started doing. So they developed this process. I'm learning this process. Alex may have more insight into this process. The way I see it is it's almost like a 6-step process. So there are multiple steps, and it is, you know, not without complexity, taking all this data from different scenarios and analyzing it to provide like an audit report back to the project of how the system might behave. But I think once you learn the process, it sort of becomes easier and easier.
That makes sense. Thank you.
Let's see when I change the way I use. So here's like, right, I got to change the way different user groups behave, how they're triggered. Then you have to collect that data. Then you input that data to see how the whole system reacts. So there are multiple steps to this.
Great. I think we're out of questions. If anyone doesn't have anything to say or unmute themselves before that. Cool. So thank you so much, Curiousrabbit, for joining us and teaching us how to use Machinations.
Yeah, no problem. If ever you guys want to do this again, let me know, and we can, I mean, I can talk with Machinations about, you know, what we can go more in depth with for specification modeling and simulating behaviors of systems and providing some sort of audit report back to the project itself.
Yeah, I was about to say, you know, that's good, because your question is really about methodology, right? Rather than, it's not about how to use the tool. It's not about we can teach you how to use the tool, but it's really about methodology. And I know that there is a lot of people out there who are looking to learn more about this methodology. That's something I need to work on at Machinations. So I also need to work a bit on working on some material to present the methodology. But that's something we are working on, and that's probably something we could also talk with you in the next future.
Yeah, and I'm sure
webinar, for instance.
If we get approval from Machinations, then we can probably take some models that have gone through the process of okay, from specification to modeling, KPIs, simulation to an audit report kind of thing.
But
I just don't have that permission.
Once again, it's not that I'm shy to give you an answer. It's because it's a methodology, right? There is no, and I cannot say this is how it should be. There is different way to do it, and it's also really tied to the type of project you're working on. So I can give some advice and some kind of framework, but yeah, it's really tied to the type of project you're working on.
That's another thing. So it's like the methodology of the TEA, which actually comes from TE Labs, which is right, your guys' methodology. It provides a great framework to start from, but I really hope we don't stop there. I want to build other methodologies. Like, okay, well, what if we tried doing it this way and seeing the outcomes, so that we don't lock ourselves in a method in a new design space right away. Machinations is a great tool for that because it's new. It's like, hey, if you can figure out a better way to do this than the methodology that we'll probably go through next time, that'd be awesome.
Yeah, I think this is a really good point. And I know that in this previous weeks, we've been doing some lectures and also having some discussions and trying to question also the ways we are doing things. And it's super important to see what works and try to advance and be better at what we do. So that's a really good point.
One of my goals, kind of goal, but not really, but one of my thoughts is, what can we develop that allows projects to get 80% done with like 20% of the work? And then the last 20% is like where token engineers really come in and are really required for like really fine tuning, right? It's almost like, how can we business canvas model a lot of the work to make it simple and easy to digest? And then token engineers come in and be like, okay, well, no, we need to switch this variable and think about these things and blah, blah, blah. Yeah, I don't know if that's a possibility, but something I think about.
Yeah, it would be amazing. And I think that's also a lot about trying to find a common ground and understanding each other. Because it's, as someone mentioned earlier about the requirements, that it's sometimes really hard to find the common ground where you can define this together, and or even for the company to, or startup to have it defined before is not always the case. And yeah, so it would be really cool if we can find something that makes it easy for the people going into token design to pin their own system down.
One of the things that I think will play a big part in that is once we identify working models, because once we have working frameworks, we can just be like, copy, paste, tweak. And we know that, okay, these are the new revenue models of Web3, just like it took time to find the new revenue models of Web2, just like it took time to find the new revenue models of Web1. Once we find those new revenue models, those new coordination frameworks, then a lot of the work gets done, and then it's just like tweaking per project.
Yeah, good point.
Cool. Well, thank you so much, guys. Appreciate it.
Yeah.
This has been fun and interesting.
A lot of fun. Thank you so much for presenting. And thank you to everyone who participated as well.
Cool. This is my first time, so it's fun. I'll be better next time.
You were great. Amazing.
All right, guys.
Okay.
Thanks, everyone.
Bye.
Thanks, everyone. Bye.
Thank you. Bye.